All right, here's 8.9. The last learning target of Chapter 8b, last learning target of the year, actually, which is kind of cool. So back in 8.8, we did powers of complex numbers in trig form. Now we're going to take roots, okay? A couple things to remember as we do these. One, if the number isn't in polar form, we'll convert it, right? Because this rule that you see up here, which I'll explain in a little bit, it needs to be in polar form. The rule applies to a number that's in polar form. As you're finding roots, know that r stays the same. You just need to find r once, and that just stays. And 3, as far as answers that you're finding, you're looking for angles between 0 and 360, okay? So I'm going to start by finding the cube roots of 8i, okay? So as I relate it back to this formula, okay, this is really big. If we're doing cube, n is 3, okay? Because you do see that come up here, and you see it there, okay? So it's really, basically r needs to be raised to the 1/3 power. Obviously, I got to find r first. And the angle basically needs to be divided by n, is more or less kind of what it's after, okay? Now, first things first, I got to get it switched because it didn't give it to me in polar form. It's in rectangular. If I want to go with a and b, right, 8i would be 0 plus 8i. That should be squared. Doesn't really matter, but technically, according to the formula, that should be 0 squared. We've seen this come up before, right? Inverse tangent of 8 over 0. Okay, that's undefined. That doesn't mean we have no solutions. It's just saying that we're looking for an angle where tangent is undefined. We've seen this before. And from there, the answer, I mean, you could just refer to this on a unit circle of tangent being y over x, right? You're looking for where x is 0. In complex numbers, we'd say where a is 0, but more or less, those are the same thing, okay? If I think about like plotting it on a graph, 8i is like up here. So it is 90 degrees is the angle that I'm looking for. If it had been negative 8i, I'd be looking for 270, okay? So we've got our complex number in polar form, okay? What we are going to do now, right, because that's z, make sure that's separate from this, okay? Formula would say z to the 1/3 power equals 8 to the 1/3, okay? Theta is 90. That goes over 3 plus 360k over 3, okay? Now, k is there just because we don't know how many times we need to add that number. In general, for the formula, at this point we do, because we know n is 3. Okay, so I need to add it 3 times because I should get 3 answers. You'll see that theme all the way through, right? If you're doing cube roots, you should find 3 of them. So really what's going on here is I'll start with 30, and then I'm going to have to add 120. You basically keep doing it until you get past 360, okay? So I'm close to getting my answers here. Cube root of 8 is 2, okay? In fact, I'm not going to call this the 1/3 power anymore. I'm going to call it z sub 1 for like root number 1. Yeah, the cube root, or 8 to the 1/3 power, is 2. And remember, that's the second part of our strategy here, is that r just stays the same. So for all three roots, r is just 2. We're kind of done with that. And here's how we'll get 3 answers, okay? First is going to be 30. Okay, that's just from 90 divided by 3. And for that case, I would say k is 0. To get root number 2, we just start to add 120. All right, so this would really be the case where k is 1. And there's the case where k is 2. Now I would stop, right? Couple things would tell me done here. Mentioned it before, okay? We're doing cube roots and we have 3. That means we're done, okay? We've got our 3 solutions. The other thing, if you kept going and you added 120 again, you would get, what, 390? That would take you beyond 360, okay? And if you do the whole thing right, you should notice that those two things happen at the same time, that it's like, oh, I got the expected number of answers I wanted, and if I did do one more, it would push me back 360, right? So no coincidence here that if we went to mistakenly get a 4th answer, our angle is past 360. All right, let's start with the product here. All right, we're going to show that these 3 roots that we found, z1, z2, z3, have a product of 8i, right? If they're all roots, right? If we multiply them all together, we should get the original number that we started with, which it would be 8i. So let's multiply them. 2 cis 30. 2 cis 150. Two times 2 times 2 is 8. For the angles, we got to go 130 plus 150 plus 270. Those all add up to 450, but if I were to take away 360, I would get 8 CIS 90, which hopefully looks familiar because when we converted our original complex number in the first place, that's what we got, was 8 CIS 90. Let's take it all the way. 8 cosine 90 plus 8 sine 90 times I. Cosine of 90 is 0. Sine of 90 is 1. Sure enough, there you go, right? Our math all checks out. Those, we multiplied those 3 cube roots together, and we got the original number that we started with. Now, to add them up to show that they have a sum of 0, right? This gets a little interesting for us because we're like, all right, let's look back in our notes where we learned how to add complex numbers in trig form. Guess what? We didn't do that, okay? So we got to convert them back over to rectangular. So I'll take that first root. And again, I'll really write out the steps here for it. The others, I don't think I need to. It'll take up a lot of space. I'm doing this again, right? 2 cosine 30. So there's the 2 cosine of 30. All of these will relate back to the unit circle. Plus r, which is 2 sine 30 I. R cosine 150 plus R sine of 150 and third and final root 2 CIS 270 R, let's see, cosine of 270 is 0. Sine of 270 is -1. Okay? I'm supposed to be showing that these three numbers have a sum of 0. Okay? So that's what we're after here. I'm going to simplify each one of these, going back to z sub 1. Those 2's will cancel, so that is square root 3 plus I. Okay? That's in the a plus bi form, right? I took that first root and I actually converted it back to rectangular. You're going to see a bunch of 2's cancel. Negative square root 3 plus I. All right, let's add these three together. Square root 3 plus negative square root 3 plus 0. So as far as the real component of this complex number with these three roots added together is 0, and that's good. That's what I expected. Now I go to the imaginary components, 1i plus 1i minus 2i. And sure enough, they add up to 0, okay? Again, the only extra little wrinkle to verifying they had a sum of 0 is we had all these roots in trig form and we couldn't leave them, right? We had to go back to rectangular form to add them up. All right, last one here, okay? Fourth roots of negative 16, okay? Get the fourth roots of negative 16. So first thing, when I use my formula, n is 4, okay? I'm going to start over here on the left. I'm going to do the conversion, right? Just to be clear here, the number is negative 16 plus 0i, right? The fourth roots of negative 16. It's a real number, right? Don't think of, we've talked about this before. Don't think of the complex numbers, right, when we involve the square root of negatives as completely separate from real numbers. They're very much related to them. Okay, we don't use them all that much, but they're, again, very much related to real numbers. All right, r is 16. We would do inverse tangent of a over b, or inverse tangent of 0. Now we got to be a little bit cautious here. Kind of think about the graphical side of things. So yeah, the real number line is right here. Negative 16 would be way over to the left, right? Because if we actually did this on the calculator, it would tell us 0. Problem is, 0 is over here, right? Negative 16 is over to the left. So we'd have to think that one through, that we want 180. That's our winner, And our number in trig form is 16 CIS 180. Right? In trig form, that's how we would express the number negative 16. All right, and move along to our formula. We are looking for the fourth roots of our number, right, which we'll call z. Remember that we really just have to do one time with r. We just need the fourth root of 16, which will be 2. Okay, and then we're done, right? All four roots, and which we're looking for here, right? And n is 4, so we should have 4 answers. For all of them, it's going r is going to be 2. (180/4) plus 360k, right? That's just saying added a certain number of times. We know because n is 4, we need 4 answers. 2 CIS, right? And here's what's going on with the angles is we need to start at 45. And we need to add 90. So for your first answer, we got 2 CIS 45, right? And just start adding 90. 2 CIS 135. Two CIS 225. Two CIS 315. Okay. Now I know I've got my 4 answers, so I should stop, right? I've got my 4 fourth roots. But again, just like the last one, it would work out perfectly here with adding 90. If I were to go to a fifth, right, if I forgot to stop, I would get 2 CIS 405, right? And I know that I don't want that angle of 405, right? It's over 360. But as soon as I go to get a fifth, theta is too big. I need to stop at 4. Okay? It says to convert them back to rectangular. I'll do one of them. Okay? I'm not going to do... Right, on the slide before when we added up the complex numbers, we did a lot of conversions back. But if I were to take my first root of 2 CIS 45, okay? So I'm converting this one. I'll leave you those other 3. Two cosine 45. Cosine is square root 2/2. Again, we get this nice deal with 2's canceling. We would get square root 2 plus square root 2i, right? Now, as you look at z sub 2, z sub 3, and z sub 4, you're going to be dealing with sine and cosine values of square root 2/2. All that's going to happen on the others is the sign will change positive to negative, right? But it's going to be very, very... Notice here, right? Both a and b were positive. That's all that's going to happen on the other 3. Some of them, a will be negative, b will be negative, right? If you have a unit circle and can get a cosine and a sine value for each of those 3 angles. Whoops. Not too bad to convert. Okay, it would just be like that first one. Okay? If you get stuck in those other 3 and we need to talk in class, we can go over how to get those 3, but I think from seeing the first, you're probably good to go. All right, that is all for 8.9. That's all for Chapter 8b. And in terms of lessons for new learning targets, that is all for trigonometry. right? Still a little bit left, a little bit of work left to do this year, but as far as introducing new content, new lessons, that's it for us, which is exciting.